Good afternoon, everybody. Welcome to another live stream with the Geo-Institute. My name is Brad Keeler. I'm the director of the Geo-Institute, and you are here today to hear about updated dam safety regulations from the Federal Energy Regulatory Commission. Before we get started, this is the first large event that ASCE has done in the past week, and so we have a quick statement. The ASCE stands with the people of Ukraine as they endure this attack on their freedom and democracy. It's our hope that peace can be reestablished and to avoid any additional casualties. ASCE and GI have members throughout Ukraine. We wish them and their fellow citizens safety and peace, and we stand with them. With that said, it is time to begin our event today. If this is the first time you have watched one of our Geo-Institute live streams, we certainly hope it is not the last. There are many fine things you can watch on the Geo-Institute YouTube channel. You can also find out more information about the Geo-Institute at geo-institute.org. And we are very happy today to be co-sponsoring this event with our friends at the Environment and Water Resources Institute, another institute of ASCE. You can find out more about them at asce.org/EWRI. We are also happy today to have a sponsor for this event, and it is Geo-Syntec Consultants. Geo-Syntec has a team of highly experienced dam safety personnel in more than 90 locations throughout the U.S. and internationally. Their client-first culture has driven the success of many dam safety-related projects for a diverse client base. In particular, Geo-Syntec's practice innovators develop tailored solutions for new and existing facilities and apply risk-informed approaches to estimate likelihoods of failure, life safety, and economic consequences, and levels of tolerable risk. You can find out more about them at geosyntec.com. With all that said, now it is truly time to start, and we are very happy today to have our host be the current chair, not for much longer, but the current chair of the Geo-Institute Embankments, Dams, and Slopes Technical Committee from the University of Illinois at Urbana-Champaign. It is Tim Stark. Tim, welcome, and thank you for doing this today.
Great, Brad. Thanks so much for setting everything up. Hello, everyone, and welcome to today's exciting virtual panel discussion. During today's discussion, we welcome questions and comments which can be typed into the chat bubble in the control panel. You may send in your questions at any time during the presentation, and our panelists will address them at the end of their brief presentation. The recording of this webinar will be made available on the Geo-Institute YouTube channel after today's presentation. Today we have three distinguished panelists to discuss the new Federal Energy Regulatory Commission regulations or requirements for all dams. Okay, our first panelist is David Kapka. Dave is the director of the Division of Dam Safety and Inspections with Ferc's Office of Energy Projects. Dave has been with Ferc since 2006 when he began as a senior civil engineer in the headquarters branch. He was appointed to the senior executive service in March 2017. Prior to joining Ferc, Dave worked as a geotechnical engineer for the U.S. Army Corps of Engineers Baltimore District and as a dam safety program manager for the Bureau of Indian Affairs. Dave, thank you so much for joining us today. Our next panelist is Eric Kennedy. Eric is a branch chief in the Division of Dam Safety and Inspections for the Portland Regional Office with Ferc's Office of Energy Projects. Eric has been with the Commission since 2011 when he began as a civil engineer in Portland. He served as the chair of the Division of Dam Safety and Inspections Structural Technical Research Group and is a member of the USSD Concrete Dams Committee. Eric, thanks so much for joining us today.
Thank you.
And our final panelist is Doug Boyer. Doug is a branch chief for the Risk-Informed Decision-Making branch of the Division of Dam Safety and Inspections, also in Portland. He has 36 years of experience in dam engineering and dam safety. Doug has been with Ferc for over 10 years, and he's a team leader for their recent revisions to their dam safety regulations and guidelines, which is the focus of the presentation today. Dave is going to start off, and he is going to outline the update, 40-year update in the regulations. So, Dave, controls are yours.
Okay, thanks, Tim. We really appreciate the opportunity to present to the group today. We're here to talk about some rather large changes to our dam safety program. As Tim alluded to, these are the first changes in our regs in about 40 years. So it's kind of a big deal for us. So as Tim said, I'm the director of Division Dam Safety Inspections at Ferc. Eric Kennedy, who will be speaking second, is branch chief in our Portland office. He's a structural expert. And then Doug Boyer is a branch chief who works in Portland for us, and he's the head of our risk program. Next slide. So to go through the presentation today, we're going to provide a brief overview of the changes that were implemented from a final rule in December of 2021, which, results in a change in our regulations. We also issued 4 new guideline chapters as part of that rulemaking. Next slide. So here's the background of our presentation. I'm going to do the beginning, then Eric's going to do the middle, and Doug will finish up. So we'll give you a little background about Ferc and our dam safety program. For those of you who aren't familiar with us, we'll talk about why we decided and undertook the revisions to the regulations, and then we'll get into the details of the revisions of the regulations, followed by the updates to with the new engineering guidelines. And finally, which will, I think, be of some import to the audience, we are going to be pushing out some training and, discussing how we plan to implement the changes, and then followed by a Q&A. Next slide. Next slide. Okay, so for those of you who don't know, the Federal Energy Regulatory Commission, or FERC, we're an independent agency that regulates the interstate transmission of electricity, natural gas, and oil. FERC also reviews proposals to build LNG terminals and interstate natural gas pipelines. And the reason we're here is that we also license non-federal hydropower projects. Next slide. FERC is headed up by 5 commissioners, appointed by the president, confirmed by the Senate. The current makeup actually has 5 commissioners, which has not been very common in the past decade. There has been some instances where we've had as few as 2 commissioners. Usually it's about 3 or 4 as folks move, and then it takes a while to get new appointees in place at the pace of bureaucracy, as I'm sure you're all aware of. But currently we do have 5. The chairman is Rich Glick, and then you can see the names of the other commissioners. They do serve 5-year terms, and they have an equal vote on regulatory matters. Next slide. So our responsibilities are pretty broad as an agency. Most of you, you all may get involved in some aspects of the electric infrastructure, gas pipeline infrastructure, those sorts of things. But we do license and inspect private, municipal, and state hydroelectric projects. Basically, all non-federal hydropower in the U.S. is regulated by FERC, which excludes federal, of course. So, we don't regulate Corps of Engineers or Bureau of Reclamation or TVA projects. Next slide. So we are spread across the U.S. We have 5 regional offices to cover the projects in the various areas of the country. The Northwest is covered by Portland Regional Office. The Southwest is covered by San Francisco. The Midwest, Chicago. The Southeast, Atlanta, and then the Northeast is our New York Regional Office. We also have a headquarters staff comprised of 15 dam safety technical experts. We have a security branch that is relatively new, that are responsible for the security of the projects that we regulate. They're located within the headquarters office as well. And then Doug's group, the risk-informed decision-making branch, is also located within the headquarters organization. We do have a staff of approximately 130 engineers and geologists across the U.S., and most of the staff are in the regional offices, as you can see from the numbers there. Next slide. So our responsibilities are broken up between the headquarters responsibilities and the regional offices. Headquarters provides programmatic oversight, the review and approval of independent consultants, which is going to be a major discussion today. We do have technical experts in the headquarters office to provide assistance on unique and difficult projects across the U.S. Also provides updates to regs and guidelines like we're talking about today. And of course, we have responsibility for responding to congressional inquiries and managing budget. The regional offices are the boots on the ground. They're the folks that do the field work for us. They do annual dam safety inspections of our high and significant hazard projects and triennial inspections of low hazards. They also perform construction inspections when we do have projects, either new construction or rehab construction. There's EAP exercises that they'll attend, and they review all the submittals that we require within our program. And they also participate in the annual or the 5-year Part 12D inspections and potential failure modes analyses. Next slide. So here's a snapshot of our inventory of projects. We have over 2,500 dams that we regulate. And of those, as you can see, over 800 are high hazard potential projects and 200 plus are significant hazard. The rest are low hazard. And for those of you who aren't familiar with the hazard potential classification, high hazard projects are those that if they were to fail, we would expect loss of life. Significant hazard projects are those that if they were to fail, we would not expect loss of life. However, we would expect significant economic damage or environmental damage. And then the low hazard projects are the ones that where if they were to fail, the impacts would mainly be to the facility itself and the owner of the facility. So, I mean, we've got a wide variety in our portfolio of projects that we regulate. We regulate from Oroville Dam, the tallest dam in the U.S., to dams that you may not even notice unless you're looking for them. We do have some that are in the 4-foot high range. And then also the kind of the spectrum of our dam owners varies from the large utility companies who own up to 145 dams, down to actual individual citizens who happen to have a dam that generates electricity. So there's a wide range in our licensees, and it does provide challenges for us to regulate, with respect to the different scale of ownership. Next slide. So we've got some snapshots of some projects across the U.S. that we have regulatory authority for. These we do have concrete arch dams, concrete gravity arch dams in the inventory. Next slide. We've got roller compacted concrete dams in our inventory, including pump storage projects. Next slide. We've got embankments, large embankments in our inventory, and you can see geographically it's all over the place. We don't have projects in every state, but we do have projects in almost every state. Next slide. And then we've got some large concrete dams, gravity dams, and you can see some of them have a lot of gates that have to operate during high inflows. So those are the projects we have vary tremendously. with a lot of different features, different sizes, and just a lot of different issues to focus on, inspect, address, analyze. It really keeps us busy, keeps the consultants busy. Next slide. And along those lines, I don't know who came up with this. It was before I came to Ferc, but someone did develop the Dam Safety Triad, which is kind of how our program functions. The licensee, the owner of the project, is ultimately responsible for safely operating and maintaining the project. But as part of our program, we do require independent consultants to be part of the mix, and they perform engineering services and inspection services on a lot of our projects. And then, of course, our staff are part of that as well. We're the regulator. We have responsibility to ensure that the licensees are implementing the requirements of our program effectively. We do that through inspections, independent analyses, and those sorts of things. Next slide. So we'll get into the revision process of our regs. Next slide. So back in 1965, the Federal Power Commission established 18 CFR 12, which stood up the requirement for independent consultant inspections to be performed on FERC projects that meet the requirements of requiring the independent consultant inspection, which is size, volume of reservoir, and hazard classification. Those are kind of the the variables that go into deciding and determining what projects require independent consultant inspection. But it boils down to basically, if it's a high hazard potential project, it will require a Part 12D inspection. In 1977, FERC replaced the FPC, and in 1981 was the last major change to the 18 CFR 12, which broke the regs into 5 subparts, including the independent consultant inspection requirements. Early, I think it was around 2002, FERC implemented the potential failure modes analysis process in our program, which was a big change in how the independent consultant inspection process was performed, and we'll get into that in some detail in this presentation. We also began requiring supporting technical information documents, which is where we expect the important information of the projects to be stored, and the analyses of record to be referenced for ease of use when items are identified and issues have to be addressed. And then in 2012, we began requiring owners of high hazard potential projects to develop and submit an owner's dam safety program to us. And the ODSP, as it's termed, describes how any one of our licensees' dam safety program is set up within their organization. So it'll describe the organizational structure. It'll go into communications. It'll go into resource allocation. It'll go into training programs, et cetera. So it's an important thing we've found over the years, that the most critical part of dam safety is the owner of the dam. We're out there once a year at most of the projects. If it's going to rely on FERC to discover an issue at a project, the chances of us finding it before it develops into something major is not very good. So therefore, the owners are the ones that ultimately have the responsibility to make sure that they operate, inspect, and maintain their projects in a basically a condition that that they can defend. And then in 2021, as I described it, it'll go into effect here in a month. Ferc Order 880, which is effective April 11th, revises the 18 CFR 12, which revises the independent consultant inspection requirements. It formally incorporates potential failure modes analyses into the regs, and it also formally codifies the owner's dam safety program into the regs, and is part of the comprehensive assessment portion of the Part 12D inspection. Level 2 risk analyses are now going to be required at FERC projects. Next slide. So one question, of course, would be why did we decide to change? Well, it's been 40 years since the last major changes to the CFR occurred. So over 40 years, there were definitely some things that needed to be brought up to the current state of the practice. We have plenty of observations from over the years. There are on average 150 Part 12 inspections performed at FERC projects each year. So there's a lot of things that we learned over the years, that we thought could be improved. And then in 2017, the Oroville spillway incident occurred in California, and following that, we had the independent forensic team report, and we also had a FERC after action panel report put together, which did provide some recommendations for improvement within the Part 12 program, which are part of what we're pushing for here. And then, like I said, we wanted to provide or incorporate the periodic updates from the Pfma process, the ODSPs, that we feel needed higher visibility by actually becoming part of the regs. The regs have are higher on the hierarchy of authorities for us. So when something's in the regs, it's easier for us, to highlight to industry of the importance. Next slide. Some of the guiding principles we had for the revisions, we wanted to adhere to the established framework from the federal guidelines for dam safety that Pfma published in 1979, and occasionally updates. We did have to be sensitive to the cost, the added burden and cost on our owners, small and large both. We aren't trying to add unnecessary cost to anyone. We know that money spent that's not necessary for dam safety, is not going to help the overall safety of the project. So we want to make sure that the requirements that we put in place are necessary and will result in more safer projects. We did want to build in flexibility where possible, and if you actually get into the regs, you'll see that in how we wrote the regs. There is a lot of flexibility for our licensees to request whether they're waivers or exemptions, things like that, and where appropriate, we'll consider those. And then we also wanted to keep what works. We did not just throw away the previous 18 CFR 12 and provide an entirely new regulation. We added and updated. Next slide. So it was a long process. It's probably why it hasn't been updated in 40 years. It was pretty daunting. We had a really good team that we stood up internally to kind of guide us through the process. Doug and Eric were two very key members of that team. But we started it in November of 2018, which once we were able to develop the documents internally, get commission review, we were able to issue a notice of public proposed rulemaking, NOPR, in July of 2020, which then put the documents out for public comment. There was a 60-day public comment period. and then we received over 1,100 comments from the public and industry. So we had to go through all those comments, and we had to at least address them. Didn't result in changes for every single comment, of course, but that process was pretty involved, and the just internal workings of trying to get a large rulemaking like this through an agency. It took some time, took a lot of pushing and prodding, but we were able to get the commission to vote it out at the commission meeting on December 16th of 2021. So it was published in the Federal Register on January 11th of 2022. So 90 days following that is when the new regs are effective, which will be April 11th, as I mentioned earlier. Next slide. And next slide. All right. So we've got in the giving an overview of the 18 CFR Part 12. We've got general provisions, which is subpart A, and this is the current, not the new ones. Subpart B is reports and records. Subpart C, EAPs. Subpart D is the independent consultant inspections, and then subpart E, other responsibilities. Next slide. So the changes that we made, you can see here, instead of inspection by independent consultant, our subpart D is now review, inspection, and assessment by independent consultant. And we added subpart F, the owner's dam safety program. Next slide. So we made major changes to the Part 12D program, which is a lot of what we'll be describing today. Next slide. So as I kind of mentioned earlier, subpart D applies to projects that are 10 meters high or higher, or have a project that impounds a reservoir over 2,000 acre feet, or has a dam or water conveyance with a high hazard potential, or is otherwise determined. And we'll see if there's many of those that meet the fourth bullet. But we thought we would add that just in case there is a project that doesn't meet those three bullets, but we determine that we do need a Part 12D inspection. So the project works must be inspected on a periodic basis by an independent consultant team, and then a report must be prepared by the independent consultant team to document the findings and evaluations made during the inspection. Next slide. So the existing program is that we have a 5-year cycle of the Part 12D independent consultant inspection. It includes document review, field inspection, Pfma, and then report preparation. The new program is going to have 2 types of inspections alternating on the same 5-year cycle. The first type is going to be what we're terming periodic inspection, PI. That's going to be a performance-focused inspection of the project features. And then the comprehensive assessment, or CA, is going to be the deep dive into the project. So each of those will be done on a 10-year interval, alternating every 5 years. So the example cycle you see there is what we would expect a typical project, who may have a comprehensive assessment due in 2025, and then a PI would follow that 5 years later, 5 years after that, another CA, and so on. Next slide. We are changing the baseline standard for independent consultants to independent consultant teams. The independent consultant or consultants must be a licensed professional engineer and have at least 10 years of experience and expertise in dam design, construction, or investigation of safety of existing dams. Currently, we just require a single independent consultant to do the Part 12D inspections. We found that expecting a single person to be responsible for reviewing, inspecting, analyzing, assessing some of our projects is really asking too much. We've got a lot of projects with a lot of, different features, unique features, et cetera, to look at. So we have decided that the baseline standard is that more than one person will be required to be on the independent consultant team. Now, it can consist of a single independent consultant with no additional team members. Now, we do allow that. We do have a lot of projects that aren't very complex and aren't very large, where one person actually can do a perfectly adequate job. But like I said, I think for the majority of our projects, we are going to expect teams, and the licensees are going to need to propose those teams. Now, as part of the teams can consist of subject matter experts who are supporting team members. So those people don't necessarily have to qualify as an independent consultant. They may not have the 10 years of dams experience, but they may have the subject matter expertise that project needs for review and assessment. Next slide. So we think the independent consultant team concept is scalable, and we do expect to have plenty of conversations with our licensees as they propose, their independent consultant team. We want to make sure that the dam type and foundation type pertinent features are considered, that the right technical disciplines are part of that team. There may be projects that have a lot of mechanical features where we actually need mechanical engineers to be part of the team. So, and then the other thing is it's trying to grow the pool. By going to this teams concept, we actually are going to be needing additional resources from the consultants. And so we want to grow the pool. And so we do expect that on certain projects, supporting team members are going to be able to develop that expertise to eventually qualify them as independent consultants. And we're looking forward to having additional folks get involved in the assessment and evaluation of dams. Next slide. And then as part of the comprehensive assessment, we are going to require the potential failure modes analysis, which we currently do. We are revising some of the details of the Pfma process. And then we're also adding the requirement of a risk analysis, which we're referring to as a level 2 risk analysis. And this is new to Ferc. Up to now, we've just had a few pilot risk analyses performed in our inventory. But now, as part of our regulations, we are requiring risk analyses as part of the Part 12D inspection program. So every project that requires a Part 12D inspection is going to have a level 2 risk analysis as part of the comprehensive assessment. Next slide. And so we've also, as part of this, developed 4 engineering guideline chapters to get into the details of what we're looking for from the STID, from the Part 12D program, Pfma, and then the level 2 risk analyses. Next slide. And with that, I'm going to be turning this over to Eric Kennedy. He's going to talk about the Part 12D program. So thank you.
Thanks, Dave. Next slide. So as Dave mentioned, the changes to Subpart D were extensive. They required us to develop an entirely new chapter of engineering guidelines to support the regulations. Chapter 16 provides details on the topics listed on this slide and a lot more that I'm going to get into. And it helps to address recommendations made by the Oroville Independent Forensic Team and the Ferc Oroville After Action Panel reports. One important note for anyone out there who reads the chapter and starts trying to use it, there's redundant information on purpose so that anyone performing a CA can look at the guidance and outlines for a CA, and someone performing a PI can look at the guidance and outlines for a PI and not have to switch back and forth and try to figure out what applies to their type of inspection. Next slide. So as Dave mentioned, periodic inspection is a performance-focused inspection of the project. The main goal is for an independent third party, not the Ferc or the licensee, to evaluate the performance of the project. And it'll typically occur 5 years after a comprehensive assessment. The scope includes a review of relevant background material, a field inspection and review of instrumentation data and surveillance reports, evaluation of project performance with respect to the identified potential failure modes, and a review of other dam safety program elements, such as hazard potential, EAP, etc. Next slide. The scope of a CEA includes everything that's required for a PI, plus a detailed review and evaluation of the STID, the design basis, the construction of the project and any subsequent modifications, and the analyses of record. It also includes a Pfma, similar to the current program, plus a risk analysis, which, as Dave mentioned, is new. A CA will typically occur every 10 years, and the overall goal of this is to fully understand and evaluate the design, construction, and condition of the project, to take a fresh look on a periodic basis as the dam safety industry changes, as we learn more about how dams perform and how they fail, and as our dams age, just to see if we need to reevaluate anything with respect to safety. Next slide. So this shows how the current Part 12 inspection, the one-size-fits-all, compares to the alternating scope for periodic inspections and comprehensive assessments. The major differences are outlined in blue boxes, but one thing I want to note is the evaluation of studies and analyses of record. While it is considered part of the current program, the requirements for that under a comprehensive assessment are much more detailed. And Doug later will cover Chapter 17 and 18 on Pfma and risk analysis. Next slide. First, for the field inspection, periodic inspection is pretty streamlined. It requires the IC team to inspect physically accessible project features. A CA, as with everything else, is a little bit more of a deep dive, and it can include inspection of typically inaccessible features. For example, confined spaces or areas that require other special equipment or extensive dewatering to access. That'll be case by case for the project. The IC team's also required to review any special inspection reports by others and test operator representative number of spillway gates. One important point on this is the IC team cannot just rely on the condition has not changed as justification for safety of any given project feature or observation. The IC team's evaluation of the project from their inspection has to stand on its own. Next slide. When evaluating performance, it's not just the physical field inspection, it also requires a detailed review of the instrumentation data and surveillance reports, more than just whether the behavior is the same as it was before. Chapter 16 provides a list of considerations that should be addressed for each project feature, which are listed on this slide. To do this properly requires the IC team to understand and describe what each instrument means with respect to performance, to understand the behavior and explain whether anything that's going on is of concern. And again, similar to field inspection observations, the IC team's evaluation has to stand on its own. It needs to be a defensible, standalone evaluation. Next slide. So now I'm going to get into some of the components that are only for a comprehensive assessment. The CA requires specific evaluation of the design and construction practices used during original construction and subsequent modifications in comparison with the industry best practices in use at the time of the CA. The IC team needs to review historic documents such as design basis reports and construction records so that they understand the design intent and how the dam was built. Next slide. The reason for this should be fairly obvious. We do things differently now than we did 2, 3, or 4 generations ago. We place concrete differently. We design embankment dam filters differently. We do a lot of RCC nowadays, and it's different than the first ones that were built in the early 1980s. We've also learned a lot from dam failures and near failure incidents. IC teams will need to understand how modern dams are built and how dams have failed so they can evaluate the previous practices and determine whether there are any potential concerns. The IC team also needs to understand the operational intent of the project and whether there have been any changes in operation that conflict with what the designers had in mind. For example, operating with a higher pool elevation or a different reservoir rule curve, or doing more frequent spillway operations for some sort of environmental mitigation. All of these could affect overall project safety. Next slide. The IC team also has to review the analyses of record. Examples are listed here and they're described in more details in the guideline. Next slide. And the IC team's review of previous analyses, it's described in the regulations, and the IC team has to address the accuracy, relevance, and consistency with the current state of the practice of dam engineering. The IC team also has to provide sufficient documentation of their rationale, whether they're evaluating the analyses as being acceptable or requiring revision. Next slide. So what do we mean by accuracy, relevance, consistency with the current state of the practice? So accuracy is pretty straightforward. Mathematical errors, invalid methodologies, inconsistent or incorrect parameters. We have had examples where we look back at a record analysis and there was a simple math error that, had it been corrected, would have completely changed our understanding of the safety of the dam. Relevance is a little more complicated. It requires the IC team to evaluate whether the analysis was set up or done properly so that it could answer the question at hand. There's an example in Chapter 16, which is a numerical model that's set up to prohibit the failure mode from occurring. That wouldn't be relevant for evaluating the failure mode because it prohibits that failure mode from occurring. Use of an invalid methodology could also affect an analysis, its relevance to the project. Consistency with current state of the practice is similar to the evaluation of construction practices. Differences between the record analysis and modern approach need to be flagged and understood. And in some cases, the IC team might have to complete some independent calculations as a spot check to evaluate whether differences between the current state of the practice and the analysis of record approach have significance with respect to safety of the dam. But we want to note that these types of independent calculations would not include like the scope of creating your own finite element analysis. Next slide. So I think Doug's going to get into the scope of a Pfma and risk analysis shortly, but from everything that Dave and I have said already, it should be obvious, why we need an IC team. It's for a comprehensive assessment, it's a lot of work, and it's really difficult to imagine one person being able to handle all of that on their own. Now, for a periodic inspection, it's more likely that a single IC might be able to handle it on their own. But the way we're going to evaluate it is whether the IC team collectively has the experience and expertise to get the job done. Next slide. And now I'm just going to show a couple of quick examples. Both of these dams were shown earlier, and you might be able to imagine that the IC teams for either a PI or CI or CA would look very different. The dam on the left likely needs some structural expertise specific to arch dams, maybe a geologist, and maybe a gate specialist. The dam on the right could use a geotechnical engineer, maybe a hydraulic structures engineer for the spillway, and maybe a geologist. Either project might need a hydrologist or a seismologist, depending on how current or critical those studies are, or perhaps an instrumentation specialist. But some of those personnel, particularly the hydrologist and seismologist, might not be necessary for a PI because the IC team wouldn't be required to review and evaluate those analyses of record. Next slide. And this is an example of a dam where a single IC probably doesn't have the required expertise to do even a periodic inspection entirely on their own. In this photo, you can see multiple types of gravity sections and embankments with some very large spillway gates. So Even for a PI, it could be helpful to have a trained eye for the embankments and another for the concrete structures. Next slide. And I'm just going to quickly cover Chapter 15. It provides guidance on the supporting technical information document and the digital project archive. Just as background, the supporting technical information was rolled out in the early 2000s with the original Pfma process. It was included as part of Chapter 14. Over the past 20 years, we've realized how critical the STID and the reference materials are to our periodic evaluations of dam safety. So now it's its own full chapter. The title, which includes the Digital Project Archive, or DPA, emphasizes the importance of having all of the original source documents available for review. The Oroville IFT report noted that the STID for that project may not have been complete and didn't contain all the references it should have. A CA requires that the IC team review the STID and DPA to ensure they're complete. Next slide. And just really quick, the STID itself is a factual summary of pertinent project information. It's meant to serve as a quick reference if somebody doesn't have access to the studies of record. And you can just think of it as a physical document in a 3-ring binder. The Digital Project Archive is everything that the STID is based on, all the historic photos, construction reports, design reports, boring logs, stability analyses, etc. It's typically been provided on like a DVD or a thumb drive at the back of the 3-ring binder. We have procedures for providing all that electronically now, but that's what the DPA is. And with that, I'm going to turn it over to Doug to talk about Pfma and risk analysis.
Hey, thank you very much, Eric. So yeah, I'm just going to spend a little bit of time to talk about the contents, what we've got in Chapter 17, which is on the potential failure mode analysis, as well as then Chapter 18 on the risk analysis. So those that might be familiar with our prior guidance, Pfma, potential failure mode analysis, was included as part of Chapter 14 of our engineering guidelines. So we've separated that out, given it its own chapter, and made some revisions based on, you can see the bullets there, from the thousands of Pfmas that we've actually conducted since the early to mid 2000s, from the comments and recommendations that are included in the Oroville Independent Forensics Team report, as well as comments and recommendations from the After Action panel from Oroville as well as the public comments we received from the draft version of this, published as part of the NOPR back in July. We got a lot of good comments from that as well. So we wanted to be able to incorporate those into, or include those into, the guidance. So just to try to highlight some of the kind of what I'll call significant revisions in Chapter 17 to the potential failure mode analysis process, and I'll go through each one of these on a slide or two here coming up, but just to give you kind of a sense, is we'll talk about, identification of the required technical disciplines, not unlike what you've heard from Dave and Eric, prior, to be able to say we need to make sure that we're having the right technical inputs, the right expertise on each project. So needing typically team members that have that kind of expertise to be able to function. We'll talk quickly about kind of revised definitions of failure and how that's changed. Understanding of how the project operates and functions is very important, and again, something that was highlighted in the Oroville IFT report, as well as being able to incorporate human and organizational factors in our thinking as far as how we actually develop, identify, and evaluate potential failure modes. And we'll talk a little bit about brainstorming of potential failure modes, how we've tried to structure that process, including how we now screen for failure modes on that, as well as some documentation process. Okay, so we'll take each one of those separately and talk a little bit more about those. So again, I'm hoping that what you're hearing from Dave and Eric and myself is this hopefully consistent theme about needing to make sure that we have the right expertise for each project based on the technical disciplines that folks have, depending on the features that the project has and the kind of the issues or concerns that might be related to the project. Again, something that I think was quite hammered home quite appropriately, I'll say, from the Orville IFT report. So Chapter 17 talks about, say, what kind of team expertise and disciplines might be required, and then trying to identify the roles and responsibilities of the different folks that might be participating in the potential failure mode analysis, and that might be a facilitator and or co-facilitators, the subject matter experts, those folks that are really kind of digging in and developing the failure modes based on their technical expertise, the importance of a note taker or a recorder and some experience that they should have, as well as other participants. There'll typically be other folks at a potential failure mode analysis that might not fulfill one of these previous roles that I've just mentioned, but still might be there either as an observer or I'll say a casual participant, somebody that may be providing additional supplemental information and things like that. So Chapter 17 tries to provide some sense of, or some discussion, I'll say, of team member qualifications for each one of those roles on the PFMA team. We talked about the definition of failure at the potential failure mode analysis as far as being revised or actually broadened from what we had typically considered. In the past, we've mostly included what's highlighted there in I'll say bullet number 1, as far as failure being an uncontrolled release of the reservoir. And now we're broadening that to include things like what's listed under number 2 there, the inability of a project feature or a component to perform their intended function, or the project features or components performing in an impaired or compromised fashion. And that can include misoperation of the project elements. So one example of that you might consider are things like what we saw at Oroville, where the service spillway, the FCO, nor the emergency spillway, neither one of them led to an uncontrolled release of the reservoir or a breach. However, I think we could probably all agree that they really didn't perform their intended functions as expected. So we want to be able to include things like that, particularly when the consequences are quite severe as a result of that. So our potential failure mode discussions need to start incorporating those types of ideas, those types of failure modes in our thinking. In addition to trying to help to I guess, better understand the scope and approach of a potential failure mode is imperative or quite important, I'll say, to understand not only the project features, but how those features actually function as a system. So those interactions, those relationships, those dependencies of the physical and operational elements of the project, to be able to put that in a systems context. So we try to emphasize that understanding really needs to happen prior to jumping into a brainstorming session to identify potential failure modes, but to make sure, again, all the participants of the PFMA have that understanding of all the different intricacies of the project, how water is released, how water is stored, what happens if a certain system goes down, as far as the potential for backup systems and redundancies, as far as operational protocols, the lines of communication that are important as far as the decision-making process, where feedback may or may not be available and what kind of feedback that might be, and the authorities and responsibilities of all the operational and project personnel to, again, understand how decisions are made and access to different project features for making releases or things like that. So again, all of that understanding has to be understood up front to really be able to start thinking as far as potential failure modes and to understand those relationships and interdependencies. We also want to include this discussion of human and organizational factors. And I think through a series of prior independent forensics team reports, I think this topic has come up more and more in the understanding that, yes, these projects have failed or have an incident that has some type of physical manifestation, but oftentimes and almost always there's been some other human or organizational factor that has some type of impact or contribution to that particular failure. And I think as engineers, we may tend to overlook things like this because this is maybe not in our wheelhouse as much as the as the details of gates and other structures and things like that. But it may be those softer sides of things, to understand the organizational factors and how the decision-making authorities and practices are actually implemented, how those are communicated, and how those have a potential to impact failure. So we've included an appendix in there at a very high level at this point to try to help guide folks that are performing the potential failure mode of how you might take those types of items and incorporate those either in the descriptions of potential failure modes or as perhaps more likely, less likely factors in evaluating a potential failure mode to start thinking in that process and how that might be incorporated in our day-to-day thinking. Again, another highlight from the Orville Independent Forensics Team report was this idea of brainstorming failure modes. And there was a criticism that perhaps we were a bit too random or shotgun approach in how failure modes were being developed or identified. And so Chapter 17 tries to go through a process to show how a brainstorming session can be more structured and methodical to possibly minimize the oversight of potential failure modes. And what's highlighted in the green box there is just trying to show as one example of how that might happen by starting at a project feature, taking just one of the components of the dam, say it's the dam itself or a spillway or an outlet, et cetera, on that, breaking it down by loading condition then. So if you take static loading, for example, and then from those, look at a failure mechanism like, say, internal erosion or slope stability settlement, something like that. And from that failure mechanism, then drilling down even further by some subcategory. Say with internal erosion, you might be looking at backward erosion piping or concentrated leak erosion or scour, and developing all the failure modes under the project feature, the loading condition failure mechanism for, say, concentrated leak erosion, and exhausting your identification of failure modes related to that prior to moving on to the next subcategory or the next failure mechanism, rather than, say, bouncing between liquefaction and overtopping and a gate failure mode and things like that. That way folks can keep structured, can keep focused on the failure mechanism or subcategory and being able to exhaust, hopefully, all potential ideas or failure modes that might be kind of developed that way. And what we've also asked, and it's included in the guidance, is to not bias oneself or constrain oneself by just looking at what had been looked at previously as far as other potential failure mode analyses and lists of potential failure modes from that, but rather use that as a checklist after the brainstorming process has gone through to be able to develop and to use those prior lists as a check to make sure something hasn't been missed in the past, kind of, and going forward from that. So we've also tried to provide a bit more structure in the screening process so that hopefully it's less likely that failure modes are screened out or not included or brought forward further into the process. And instead of having 4 categories of potential failure modes like we've had in Chapter 14, we had, again, those that are familiar with the Pfma process for Ferc, had a category 1, 2, 3, and 4 for the different failure mode categories. We now are trying to break those out into some additional groups. So they're shown there in the bullets, the ruled out, the clearly negligible, the credible, urgent, and things like that. So I realize you can't see this flow chart just on the screen, and I've tried to break it down a little bit for you here. And it's based on the failure definition. So we've tried to group kind of how you proceed through a flow chart like this in being able to come up with a disposition, a binning process for each one of the failure modes and how to consider that. And I won't go into detail with that here, but just to understand that there is kind of a new kind of stepwise process to be able to work through, so that should be systematic of kind of where these failure modes end up by asking oneself a series of questions going through this. And then finally, in Chapter 17, we've tried to provide some suggested or potential templates and things like that to help with the potential failure mode analysis process, mostly to help ensure that things aren't overlooked, so that you can use the template to be able to capture those kinds of information. One can use that again to make sure something's not overlooked, as well as report outlines, example justifications for why one might exclude certain potential failure modes, and what examples one might use as far as actually the words to justify those, and how summary tables of potential failure mode analyses or potential failure modes could be put together. Moving on to Chapter 18. Again, this is a new chapter for us in our engineering guidelines. This kind of highlights a hole that we've had in our existing RIDM guidelines, our risk-informed decision-making guidelines that were published in 2016. And this is this level 2 risk analysis that we've referred to it in our guidance. A level 1 being a much higher level, less sophisticated risk analysis that one might use for looking at an inventory of say common dams with one owner or something like that. The level 2 is one level more sophisticated, and we also have 2 other higher levels of risk analyses, the level 3 risk analysis and level 4, where we're starting to get into more quantitative type risk analyses and quite frankly, less failure modes. These are more kind of issue evaluation or issue specific types of risk analyses. So the level 2 risk analysis follows an approach that's documented, and it's very similar to what the Army Corps of Engineers and Bureau of Reclamation refer to as a semi-quantitative risk analysis in their best practices for dam and levee safety risk analysis documentation between the agencies. From our standpoint, we felt like we needed to provide a bit more guidance to our licensees and consultants than what that chapter and best practices provided. So some of the templates and other guidance related to that. So some of that includes, we wanted to find from our agency what risk measures that we wanted to include in the level 2 risk analysis. It talks about qualifications of team members, how one might estimate the various loadings, an overview of the overall process from the level 2 risk analysis perspective, failure likelihoods and consequences and how those are estimated, how we would like those risks portrayed in a report, and then finally the documentation. And again, we'll cover each one of these in just a little bit of detail, just to give you a sense or a flavor of what that includes. So Chapter 18 goes through the risk analysis measures and identifies those risk measures that we want to see in a level 2 risk analysis. That includes the life safety risk from a societal or incremental standpoint. That's the most common risk measure that most folks doing risk analysis are probably familiar with. But it also includes non-breach life safety. That non-breach is estimated as if the dam actually didn't fail. It's actually performing its intended function. But even with the releases downstream, say during flood flows, that might have the potential to actually impact life safety associated with that. So it's important to understand and know where you might have actually non-breach life safety implications on each particular project, as well as annualized probability of failure is the third risk measure. Chapter 18 also goes into more detail as far as also suggesting that one might also include other risk factors like economic or other consequences like environmental, cultural, etc. When those consequences could be quite significant and may impact how one might evaluate a prioritization as far as what failure modes, what actions one might take. So we wanted to at least acknowledge that as well. As I mentioned, in Chapter 18, the risk analysis chapter talks about the team aspects of the expertise and technical disciplines that might be required, their roles and responsibilities, not unlike what Chapter 17 mentions, as well as the qualifications of the team members, including those of a risk facilitator versus the subject matter experts. Now, we also recognize that as an industry, we're really starting to kind of just work our way down through this process, and there might not be a great depth of experience within industry for all of these. So we're going to have to take that under consideration, particularly for the first year or two, until we can develop a deep enough bench. But Chapter 18 kind of sets the bar relatively high for the long term as far as what would be the requirements for the qualifications of all the members. And you can see some of the things there as far as what would be required versus recommended, even from a risk facilitator standpoint. And Dave will talk a little bit at the end about the implementation and the training aspects of that, of how we at Ferc are trying to help make sure that industry has that expertise through training and things along those lines. There are some other important limitations from a risk facilitator, and this is to try to, again, minimize or reduce bias that might have a chance to be able to enter into the process. So, for example, facilitators, can't have served as the engineer of record for or contributed substantially to a significant analysis, design, or construction aspect. And I think you can understand the reasons for that. The owners themselves or their staff are also not eligible to serve as a facilitator for a risk analysis on their own structures, as well as individuals that serve as from the owner's dam safety program process identifies a chief dam safety engineer or a chief dam safety coordinator, a CDSE, or other members of their organizations are not permitted to fulfill the facilitator role on the projects at which they provide such services. Again, to try to reduce that potential for bias to be able to enter into the process. So Chapter 18 goes into a high-level overview of probabilistic loadings. Again, these are quantitative estimates from the standpoint of the frequency of loading from a hydrologic as well as seismic loading. I think industry is probably better or more familiar with doing PSHA's probabilistic seismic hazard analysis than maybe from the flood aspect. But there are methods out there. I say in industry, the Risk Management Center at the core provides some good documentation as far as how industry might go about that, the methodology and approach. We will be providing training on that as well, as far as to try to help industry to understand what the expectations we have of being able to develop these probabilistic seismic hazards. The other aspect of that, again, that industry probably hasn't had a lot of experience doing, at least at this point, are the consequence estimates. So that's namely life loss, human life loss from that. And so there are a number of different methods to be able to do that. We try to provide some guidance on when you might go with certain types of methodologies or approaches to be able to do the consequence estimates. And it really is a kind of a project by project specific approach to be able to do that. And then the overall kind of risk analysis process, again, is laid out more in a flow chart to take the information that you might get from a potential failure mode analysis there, that upper orangish rust color box there, and then taking the information that you get from the loading frequency from the hydrologic and seismic and combine that with the estimates that you get of the consequences to ask the question, is this potential failure mode actually potentially significant or not? Again, there's a screening process that one goes through to see if you could actually exclude the potential failure mode from the overall process from going into the risk analysis. Otherwise, it passes into the risk analysis, and then using the information on the response and the consequences, you can develop estimates and likelihoods for each one of those, combining those to be able to look at the risk itself, determine its confidence and uncertainty in a risk estimate, identify any risk reduction measures or management activities that one might consider to reduce the risk of that particular potential failure mode, and then how we like to have that plotted and documented in the report. So again, all that's highlighted in Chapter 18. Again, Chapter 18 goes through the secondary kind of screening process that goes on at the risk analysis phase. The left-hand side of this slide goes through the potential failure mode process from the brainstorming to the initial screening of that, and then taking those failure modes that at the Pfma sense, or at the end of the Pfma, those credible and insufficient information kinds of failure modes, to again screen those with the consequences and the likelihood, the potential, the probabilistic loadings, to be able to see if those are actually potentially significant and whether those get carried into the risk analysis itself. So then Chapter 18 goes into quite a bit more detail on these next two slides on the risk analysis failure likelihood approach and how one might look at each failure mode perhaps differently, and what approach one might take to actually come up with failure likelihood estimates. So Chapter 18 identifies 3 different ways one might approach developing failure likelihood estimates. The descriptive approach, which I think most that have done these through the pilot studies are most familiar with, are using the tables, for example, the table there that you see on the right-hand portion of that slide, and looking at some descriptors on that based on the information that one has discussed during each potential failure mode for the more likely or less likely evaluation factors for each failure mode, and trying to use that information to kind of categorize that or bin the likelihood of failure. Other approaches include a critical load approach that involves a bit more explicit estimation of the annual probability of failure as far as looking at what critical load level might be appropriate. And again, that's more appropriate for seismic and flood kind of failure modes where you've got the probabilistic estimates of the frequency. And then finally, there's the quantitative approach, where one can use an event tree or fault tree or some method like that, where you can go through nodal estimates to try to develop your likelihood of failure estimates yourself. And then the risk analysis and developing the life safety consequence estimates. And again, there are 3 different approaches to this: a descriptive approach, empirical approach, and a simulation approach that models life loss. And for folks that are more familiar with the simulation approaches, that might be something like a life sim or something along those lines. So that's included in Chapter 18, as is how we would like the risk analyses to be portrayed. So there's a template there for each risk measure, whether it be life safety, whether it be non-breach or probability of failure, and that's all provided in there, as well as a total for each of the failure modes that could be estimated from the process. And like the potential failure mode analysis chapter 17, Chapter 18 goes through through appendices to provide report outlines and example justifications and templates to be able to capture all the information that might need to be captured during a risk analysis process. And with that, I'm going to turn it over to Dave to talk about implementation and training.
Okay, thanks, Doug. Next slide. All right, so we generally or currently have about 750 projects that require Part 12D inspections. So that works out to about 150 Part 12D inspections per year, since it's on a 5-year cycle. Since we'll be doing half of those as periodic inspections and half as comprehensive assessments, we're looking at, when we're fully implemented, having about 75 comprehensive assessments per year. And that's a lot. It's a lot for industry, it's a lot for our licensees, it's a lot for Ferc staff. So we're gonna have to ramp up. So we're currently developing the implementation plan for this. One of the decisions I had to make over the past couple years was whether or not to divert resources to developing an implementation plan ahead of the regulations becoming effective. And with the uncertainty if the regs would ever be changed and when they might be changed and what they might look like, I made the decision to wait. And so now we're paying the price a little bit, but we're working diligently on an implementation plan. The first projects under the new Part 12D inspection process are not going to be required until due dates of October 2023 or later. And that's because we have an 18-month lead time required. So on April 11th, our new regs become effective. And so 18 months after that is going to be October of 2023. So until October of 2023, the expectation is the Part 12D reports will be done under the current program. There may be discussions here and there with some licensees who would like to move to the new Part 12D process, but most of them have contracts in place with consultants and have been planning towards their Part 12D inspections under the current requirement. So it's not something we can just change on a dime. We are thinking that we're probably going to have about a 4 to 5 year ramp up to full implementation on the comprehensive assessment side. As you probably gleaned from our discussions so far, the periodic inspections are going to be less intensive than the current requirements of the Part 12D inspections, and the comprehensive assessments are going to be more rigorous than the current expectations. So the comprehensive assessments are the ones that we're going to have to phase in over time. So I'm working with the regional engineers to go through the list of candidate projects in the first year. And we're trying to identify about 15 to 20 of those, so about 3 to 4 per region. And then we'll be ramping up incrementally from that point. There's many screen factors that we can and are using. Certainly higher risk projects may lend themselves to us wanting to have comprehensive assessments initially. Projects that may not have, a full knowledge of design and construction, the comprehensive assessment process is designed to get into that in a deep manner. And there's other factors as well. We don't want to overburden specific licensees who may own a few projects or may have a few projects that are due in 1 year. And then we may not want to learn on our comprehensive assessments on all the difficult high-risk projects either. We may want some more run-of-the-mill projects to build the knowledge base, both internally and externally. And we also want to distribute those across the regional offices. But the ultimate goal is to have each project to have a CA by 2038. So as we work through the implementation strategy, we'll be passing that information on to our licensees in the coming months. And I've been communicating that already with them through various venues, and we'll continue to do so. My internal goal is to have the whole next 15 years planned out by the end of this calendar year. We'll see if that's achievable or not. Next slide. So the other half of the implementation strategy is to provide training, and this is both internal and external. We need to train Ferc staff on the new requirements, as well as to train licensees and consultants. So we're developing those courses now. And so here's kind of a listing of some courses that are either currently available or ones that we're starting to develop or will have assistance developing. So USSD has a leveraging PFMAs for SQRAs course that would likely provide a lot of the knowledge base for the level 2 risk assessment that's required in our program. The best practices course that Reclamation and the Corps offer also gives a really good foundation in risk analysis that would be very beneficial. And then we're looking at developing specific courses, overview the changes. So it would be a little more in depth than this that we're giving today. We'll get into a few of the more specifics, kind of targeted at our licensees, so that they're fully aware of all the changes in the regs, and that they'll have the opportunity to have some interaction in that course. We're looking at a PFMA and level 2 risk analysis process course. As Doug laid out, the PFMA process is changing. Obviously, we need to make sure our staff and the licensees and consultants understand the new changes. And then, of course, the level 2 risk analysis process is new. So that'll be part of that as well. We're hoping to get those in place in June. It's a heavy lift, but we're going to be targeting June. Risk facilitator training. We're working with USSD on that, and we're going to see if they're able to get something in place by June. We're thinking that's probably about a 2.5-day course. The risk facilitator is going to be a very important team member on the Part 12D inspections, the comprehensive assessments. So we need to make sure, that we have enough training available. Now, there's folks out there currently that are likely experienced enough and have gone through enough of these with other agencies or elsewhere. But we want to once again kind of build that pool in the consulting community, so that when we are having 75 comprehensive assessments in 1 year, that we have a big enough resource pool to get that accomplished. And then we're also working with the Corps on development of a hydrologic hazard analysis for SQRA course. We're looking, that might be a 2 to 3 day course. It's going to be take a little longer to develop, so we're thinking maybe August timeframe. But once again, as we develop these, as we finalize timelines, you can go on ferc.gov, you go to our website, and we'll be posting updates to industry, to the public, on the availability of these courses. We're certainly looking at these are likely to be virtual and recorded, so that once they're completed, we'll park them on our website so that folks that weren't able to make it, can view them. But we'll, like I said, we're working on that process. And I think that's it. Next slide, Doug. So really appreciate your all's attention today and letting us talk to you about our program and the changes. They're a really big deal for us and the non-federal hydropower industry. So appreciate your time. And now I think we're going to do Q&A.
Great, Dave. Thanks very much. So we've got a bunch of questions. First, what agency regulates dams that do not include hydropower generation?
The answer is a lot. Mostly it's state agencies. So each state, I think except for Alabama, has a state dam safety program, and their statutes are set up. And some states exclude certain types of dams or certain size dams, et cetera. But the state regulators regulate a lot of the dams that we don't regulate, as well as other federal agencies. Most other federal agencies are owner operators, so they kind of self-regulate. So the Corps of Engineers is responsible for their own projects. Reclamation's responsible for their own projects. TVA responsible for their own projects, and a lot of the other agencies as well within Department of Interior, Fish and Wildlife Service, Forest Service. So it really depends on who the owner of the dam is, what the function of the dam is. But it's typically, if it's not a federal dam, and if it's not a hydropower dam, it's likely the state that would regulate it.
Okay. Are there safety requirements equivalent for dams that do not generate electricity? In other words, similar requirements?
Yeah, so it would be state by state, or federal agency by federal agency. Most federal agencies follow the federal guidelines for dam safety, and there's some requirements that are laid out in those that kind of govern loading criteria, et cetera. Corps of Engineers, Reclamation, and now TVA are moving towards risk. So a lot of the criteria that they use for measuring their safety of their projects are in the risk realm. But most of the state agencies aren't incorporating risk yet. And so their standards are state by state. So you'd have to go to the state dam safety website to see what the requirements are for those dams that aren't federally regulated or aren't owned and operated by the federal government.
Okay. How will the Ferc staff annual inspection change as a result of the changes in the consultant review process?
Yeah, so I don't see a lot of changes to our inspection process. We do annual inspections that are separate, from the owners, and they're separate from the 5-year consultant inspections as well. Now, when the 5-year or now the 10-year, PI or CA occurs, we'll certainly be part of those processes. But I don't see really much change in our annual inspections. Certainly, to inform our inspections, we'll review the documentation for the project ahead of going out. So a project that has received a comprehensive assessment will certainly have a lot of information that the inspector has to review and be, be up on. But mechanically, there's not going to be any change to our inspections.
Okay. Next question is, were the final regulations weakened in any meaningful way in response to the public comment process? Did any changes negatively impact public safety?
Yeah, I would say not. We didn't make too many changes, and I think if folks really want to, they can go back and look at the original proposed regs and then the final and compare them. We did make some tweaks. We did make some changes in the guidelines to respond to comments, but I don't think we would say anything was weakened through that process.
Okay. With rapid climate change, significant changes in watershed behavior occur over as small as a 10-year period. Is there specific guidance regarding how this uncertainty must be addressed?
Well, I mean, the climate change question is a tough one. It's really tough to make project level decisions on these climate type models. So we're not there yet. And I know there's a lot of research, and we're certainly interested in, the outcomes of that. I will say that our high hazard projects, by and large, have to safely pass the PMF for flood loading, which is an extreme flood. So, with respect to something changing between comprehensive assessments, as far as flood frequency, those types of considerations, I think our projects are still designed to really high standards as is. But of course, as more information becomes available, as we can start making project level decisions, based on better climate data, we'll do that. And we do require reassessments of projects after large floods of record. So, where those happen, we already are looking at it, and we'll continue.
Great. Next question. If reminder letters have been sent out documenting requirements for 2022, do those still apply, or are they superseded by the new rules?
The Part 12D reminder letters that have been sent out for 2022 are going to be in place. So like I said, the first required new Part 12D inspections will be October 2023 and later. And I would only expect, there may be a licensee here and there who are interested in following the new requirements, and, they can approach the regional engineer to discuss that opportunity. But, we're not going to be requiring someone in 2022 to follow the new requirements.
Okay, so starting 23. Okay. Are there any provisions/concerns for COVID-19 outbreaks that may affect scheduling to assemble Part 12D as in David inspection teams?
Well, we won't know, unfortunately, until we're later and on down the road. So there may be. I don't know the answer to that. These won't be until 2023. So hopefully COVID won't be as big a deal then, but we all don't know that. So there may be considerations that we have to consider.
Right. Early in the presentation, you mentioned there are FERC projects in most states, but not all. Which states do not have a FERC project?
Figured I shouldn't have said that because I'm put on spot. I know Hawaii doesn't, because I would be inspecting those if we did have them. I think North Dakota does not have a FERC project. I think every other state does, but I could be incorrect. There are states like Arizona that have very few, but I think I know North Dakota and Hawaii do not. Otherwise, I do think there's probably a FERC project in every other state.
Right.
And Doug and Eric can chime in if they know I'm wrong.
Okay. How do you get involved in the inspection teams? And I think they're asking about FERC inspection teams.
Yeah. So the process, our licensees, and I've been saying that term, so I apologize if people are wondering what the heck a licensee is. That's what we call our regulated entities. So the owner of a FERC project, we'll call them the licensee. They hold the FERC license. So we require our licensees to propose to us, the independent consultant currently, and then to be the independent consultant teams. So it's going to be the dam owners that will be reaching out to industry, to put these teams together. So like I said, it's the non-federal hydropower owners, a lot of large utilities, municipalities, some states, and then some individual citizens as well. Although most of the individual citizen-owned dams aren't high hazard projects, so they probably wouldn't fall into this, but there are occasionally a few here and there. So to be part of the independent consultant team, you need to be nominated through a proposal by the licensee of the project.
Right. I noticed Doug said the definition of failure changed or is changing from release of the reservoir to include, say, components. So how does that differ from before, where it was failure and dam incidents?
Yeah, there needed to be, I think, a better focus on the definition of what we want the PFMA process to do. And after Oroville, there were debates about whether, that was a uncontrolled release of the reservoir. Mm-hmm. I certainly believe that it was myself, but the arguments could be made, well, it didn't fail, the spillways held, whatever. To me, that's an unacceptable incident. So we just didn't want to get into, the verbiage battle with folks. So a situation like Oroville, has to be considered a failure now through the PFMA process. Those types of failure modes need to be looked at. So even if the team determines that ultimately, there won't be a breach and a full release of the reservoir, they need to go through the process of, whether or not there will be significant consequences from a failure of a component or a system. So that's kind of what we're thinking there. And Doug or Eric, you can chime in if you want to add color to that, if you want.
Yeah, this is Doug. I think the real intent was to make sure that things like the Oravilles weren't being screened out because they had been in the past. So if it didn't lead to a breach itself, then that failure mode was kind of cast off or put into a different category and wasn't given kind of due consideration in evaluating that, and not recognizing that failure mode could still lead to very significant consequences on that. So we wanted to be able, like Dave said, kind of capture those rather than overlooking those, to make sure that we were really giving due consideration for all the potential failure modes that could provide some type of adverse consequence or impact, either to life safety or to the owner.
Okay. So let me throw an example. What about an upstream slide? The reservoir is not lost, but there's a slide upstream. Incident, failure?
That's up to the PFMA team. They would need to evaluate that failure mode. And if truly there was no consequence to that, other than, repairs by the owner, perhaps that would go into one bin. However, if it would require a response, such as a drawdown of the reservoir, or if it would impact intakes, those types of things. I mean, I think, that scenario could go many different ways, and we would want it to be fully looked at.
Right. Okay. I think that's all the questions we have. Brad, do you want to jump back in and wrap us up?
I will always jump back in, Tim. Great job, everybody. And thanks to all our viewers for sticking with us today. We really appreciate it. If you liked what you saw, and like I always say, I think you did because you're here at the end, you should click subscribe. You should click get notifications. We'll let you know every time we post something to the YouTube channel. You can give this video a like too and help it appear in other people's search results. A great presentation by Ferc today. You guys did an amazing job. Clearly, there's a ton of interest on this. We will be announcing shortly part 2 of this series, which will feature consultants replying to the regulations. That'll be on April 12th, so something you can look forward to. Look for that on the YouTube channel or on our Eventbrite page. Definitely check out other GI programs at geo-institute.org, EWRI at asce.org/EWRI, and thanks again to our sponsor, GeoSyntech, for helping us out today. So thanks again to our presenters. And to everybody out there, I hope we see you for part 2 in April.
Yep. Great job.